application continuation now will be done now. I'm sharing the screen. Share your entire screen. Okay. Rajat Kumar. Rajat Kumar. Rajat Kumar, quickly speak. What you are seeing now, Rajat Kumar? Ranveer Singh. What you are seeing now on the screen? Figure, sir. Okay, thank you. Now let us continue. Okay. Events. Okay, fine. So this diagram I have shown in the previous class, and this is the Earth surface. Cross sections of the Earth. It is handwritten. It is not the actual one. By using a convention, they have written at the bottom. At the bottom here, magma is there, and see magma region. So here, high temperature. This is. Look at this. High pressure and high temperature. High pressure and high temperature, and various earth, rocks, soil, various things will be present. Through that, the it will steam will emerge. See here, from let's assume here. You see, wherever the hole is there, vent is there through the rocks or the mud, it will come and escapes. And this is the hot water spring. So temperature is 212 degree Fahrenheit. It means 100 degrees Celsius. This I have shown in the last class, but just I will repeat it. I'm repeating it. Whereas the higher temperature and higher pressure, that steam, it will escapes like this. It's see, this is called the fumarole, and the temperature is 400 degree, 450 pressure. This is how we utilize this entire thing makes the classification of the geothermal energy plant. Okay, this is one hydrothermal geothermal plant they are showing here. The diagram which is shown below here. Here, this is the steam well. They will drill it, and some means they will take the steam. That steam, it flows like this. Then that is taken to the steam drum, and here separation of the particles takes place. Moisture separation takes place. That flows to the another valve, Then that it goes to the turbine. From the turbine, it goes to the condenser. From the condenser, it goes to the it is condensed. That can be connected to here. Then again, it can be recycled. Like this is the path of the flow of the steam. I think I'm repeatingly I'm drawing the closed path circuit so that this is the movement of the path of the steam. So this is the steam flow circuit path. This is the working. Later on, this generator is coupled here. The generator generates electricity, and for cooling of this one, condenser is present here. For that condenser, cooling water is necessary for circulating the cooling water. That cooling water is circulated here like this. Cooling water circulation, I will show you separately now. How the cooling water is circulated, I will show it to you. Say, circulating pump, cooling water enters here. Then it flows through the tubes. Then it is cooling the steam coming out from the turbine. After cooling, it becomes hot. Then it is spread over the cooling tower, and then from the cooling tower, it is circulated through the pump. One second. This is the path of the cooling water. This is the circuit of the cooling water. This is circuit of the cooling water. If you understand this one, all the classification of the geothermal plant or geothermal energy utilization, you can understand easily. Very small difference will be there. With that small difference, it takes a different classification name. That's all. Okay. This is the general hydrothermal energy utilization. Now let us, after understanding this, okay, with this, do you have any doubts? Any student have a doubt in this one? You can raise the hand. You can ask the questions. Do you have anything to ask in this? You can use that hand raising icon. If you do not have, I will proceed to the next one. Okay. Now you look. Are you able to see this one? Geothermal, chapter 9. Put it in the chat box. Shiva Krishna. Shiva Krishna, put it in the chat box. Are you able to? Rajat Kumar, no, sir. Now I have opened. Now I have opened geothermal energy, chapter number 9. Are you seeing this one? Okay, Shiva Krishna, yes, sir. Rajat Kumar, you put the message in the chat box as no, sir. Now, are you seeing this one? See, now I have made it open. Now, are you seeing this?
Visible, sir. Visible, sir.
Okay, thank you. Right. Now let us go ahead. See, this is this reference material I have scanned from the your non-conventional energy resources written by the author B.H. Khan. By that book I have taken. This is according to your syllabus. So this itself already I have sent to your email ID and I have added in the Google Class also. You can see that one. See your email. All course material I have sent it, which is written according to your syllabus. Yeah. Here, this is all introduction is there. Just once or twice, just read it and leave it. Applications. Okay. First, let us see the origin of geothermal energy. Look this. In your syllabus, they have made it as origin of geothermal energy. It is like this. They are given origin of geothermal energy. This itself, this diagram. This diagram is written like this, whereas in the previous diagram, previous screen, the cross section of the earth by using a convention they have written, that I have shown. I feel that is more clarity. There is a more clarity than this one. But anyhow, you can get the information. Look this. This is earth surface, crust, earth surface. Depth we are going like this. So 30, how much kilometer we go? 30 kilometer. 30 kilometers is just a minute. Earth crust. This is here. This and this. This distance, small distance is 30 kilometer. I hope you understood. And beyond that we are going depth, where this portion is called the mantle. 2,900 kilometer up to mantle. Next, again we go depth. 5,150. This is outer core. Again we go depth. 6,370 kilometer. Inner core, 4,000 degrees Celsius. This is where the magma is present. Magma. To the magma, we cannot take any pipe to insert in this one. Otherwise, pipe will melt. And also, such a long distance, we cannot practically we cannot take it. Hydraulic losses will come. Loss of energy will come. This is about the origin of geothermal, and all explanation you have heard about. Okay, this is the geothermal energy is the heat that originates from the core of the earth, where temperature are about 4,000 degrees Celsius. Okay. Now let us come back to this geothermal applications. So geothermal energy, wherever it is necessary, there we can use the geothermal energy. That's all application. But however, they put it under the different headings. The different heading you have to know it. So one is direct heat use. Next is electric power generation. Under these two heading, they have put that one geothermal energy application. But in other book, they make this itself as another 3, 4, 5 agricultural purpose. Also, they will say chemical process industries. Also, they will say. Then a number of classification it difference applications. But in the textbook prescribed for your syllabus, they have given like this. Let us follow that one. And direct heat use is see, geothermal energy resources have a great range of temperature. Its thermodynamic quality is low. The source share many similarities with industrial waste heat. The low and moderate temperature hydrothermal fluids, they call this one as hydrothermal fluids, can be used as direct heat source for space and water heating for industrial process such as drying application in food, chemical industry, textile industry, crop drying, washing, warming fish ponds, aquatic, agricultural applications, space heating of glass house. Like this, number of examples we can quote it. One example is 1000 megawatt plant might serve an urban area of about 20 kilometers and 20 kilometers. Such geothermal schemes have long been established in the Iceland on a smaller scale in New Zealand. Look, focus here. Iceland and New Zealand. Why this Iceland is taken in the entire world? In Iceland, these hot water springs and high temperature fumaroles are there. That is why I highlighted this one. Look at this. 80% of the population of Iceland use geothermal space heating. More than 9,000 thermal wells and springs are now in use. It has become a tourist place now. Now, electric power generation, as usual, whatever the sketch and explanation, whatever you're writing, all these things become the electric power generation. Particularly in the wherever the natural sources are there, geothermal, hilly areas, and Jammu and Kashmir, and etc. Gujarat also some place there. Uh, they call that one as the geysers. Okay. And geothermal energy electricity generation table they have given. They go on the table. Don't look into this table. Just for curiosity sake, you can see and leave it. Indonesia highest always recent some four, 4 years back in Indonesia, this Jwalamukhi, the volcano has erupted. Bali, very beautiful tourist place, Bali, international airport. There also it has uh, that volcanoes have spread, and a few months it is stopped. Beautiful place on the earth, Bali, Indonesia, tourist place. I know this is not in your syllabus. You need not worry. Not in the syllabus. This is not necessary. Those are this is just some statistics. It is number. Now origin is over. On the map they are showing where all it is there. It is all geography. You need not worry much. Region of seismic and volcanic activities encircled under tectonic plate boundaries. In India, it is not there. India is the safest place from these points of view. Types of geothermal resources. This types is there. Look this. Okay. These are types of geothermal resources. There are 4 types geothermal resources. One is, look this, hydrothermal. The previous sketch of a geothermal plant, what I have shown, that is a hydrothermal. That is the steam is taken from the earth surface. It is fed on the turbine. Turbine rotates the electricity generator. The sketch I have shown, no, electrical energy production. That sketch comes under this hydrothermal. All are hydrothermal only. Others are not in practical application. Next type is uh, geopressurized. Next is hot rock geothermal resource. Magma type geothermal resource. Uh, okay. At present, say at present, the technology for economic recovery of energy is available for hydrothermal resource only. Note this point. That is this one. Hydrothermal is practically used. This hydrothermal, geothermal resource is practically used. All others are high temperatures are there, which is not practically, technology is not developed to use that one. Now coming to this hydrothermal, each one by one. So now look at this hydrothermal resource. So this is what this Earth surface I have shown in the previous class. So here the heat region is there. So it is coming like this, and this is the well, and this is the plant. Steam is taken here and here, and it is electrical energy is produced. In this, in this hydrothermal resource, uh, one is vapor dominated, another one is liquid dominated. A little difference is there. Now let us focus on that little difference. For practical purposes, hydrothermal resources are further subdivided into vapor dominated and liquid dominated. Liquid dominated is wet steam. This is dry steam. That's all. How it is dry steam and wet steam? Let us look. So coming to this vapor dominated. See, this is the production well. From this, steam is taken. That steam rises here, and that is taken like this, and it is fed on the steam turbine, and that steam is taken to the condenser, and then it is re-injection well. It is sent back to this one. It goes like this. Okay. And a solid matter and all, it is a centrifugal separator. They will separate the particles present in the steam. And the generator rotates. Electricity is generated. So they are for this condensing, cooling water they are supplying, and then that cooling water is sent to here. Then this is the cooling water circuit. That is the cooling water circuit. And the non-condensable gases they are sent into the open atmosphere. This is the dry steam hydrothermal system. See, this is dry steam. Look this dry steam. They will take like this. Look this dry steam. This is the dry steam flowing. Since only at high temperature dry steam is taken, this is called the dry steam hydrothermal system. Hydrothermal system is practically used one. For this hydrothermal dry steam, like this it is. Now let us look the same hydrothermal but liquid dominated. It is wet steam. It's say again in the wet steam two are there. High temperature above 175, low temperature below 175. Two are there. Now let us look liquid dominated high temperature system coming here. Same production well, and because of high pressure, high temperature, when the steam is taken and it is sent to this one, the flash chamber, flash separator. Here the vapor comes this side, the liquid as a brine goes to the bottom, and this is direct thermal applications it is taken, whereas this vapor, that vapor is taken here as a dry steam, and it is sent passed over the steam turbine, and it is condensed, and it is sent to the reinjection well. And for this cooling, uh, okay, cooling water is passed like this, and it is sent to the cooling tower. And the generator is there. The generator rotates with n rpm. It goes like that. Now it is a single flash. The single flash is enough. This two flash is not necessary. Double flash is not necessary. It becomes unnecessary more in syllabus. By chance in the examination, if they ask two flash, just instead of using one, you use it two. And instead of one turbine, you use it one, two. Two turbine you use it. Enough. That's all. So don't waste your time on this one. Now coming to the liquid dominated low temperature. So if the low temperature is there, see liquid dominated low temperature. If the low temperature is there, this flash absent. This is absent, low temperature, because flashing does not occur if the temperature is low. Now you see, uh, temperature range 90 to 175 degrees Celsius, which is the low temperature, is not enough for efficient flash steam production. A binary fluid system is employed. Okay. So that is this one. Production well, it is taken here and sent through this, and it is re-injected. And this heat is given to fluid flowing through this. And afterwards, this entire thing is same as all any other Rankine cycle, turbine, then condenser, cooling tower, generator. It is the same as that one. Okay. Now coming to the geopressurized resources. Uh, while drilling for oil and gas, hot salty water brine reservoirs at moderately high temperatures, 90 to 200 degrees Celsius, and under great pressure are found at a depth of 3 to 6 kilometers because of the very high pressure of the water up to 1350 atmosphere in the deepest layer. Say 1350 times the atmospheric pressure. Such a enormous large pressure is present in the deep earth layer, deepest layer. Uh, these reservoirs are referred to as geopressurized. The question is, no technology, no technology is developed at this pressure. The enormous pressure, this is high pressure. So nothing can withstand. So that is why geopressurized is simply a theoretical one. But by alternate some method they will use it. Hot dry rock resource. There are regions underground at temperature exceed 200 degrees Celsius with little or no water. Okay, such as like this. Here, these are all the granite. Here, fractures will take place, and this hot water they will take and pass like this. That's all. That's all the hot dry rock binary fluid. Why they call binary fluid is one fluid is flowing like this, another fluid is flowing like this. This entire thing is as usual your Rankine cycle. This is as good as your same. See, turbine is present, generator is present, condenser is present, cooling tower is present, heat exchanger is present, and freon vapor, they can use it. So that is why they call it as a binary fluid. So that's all. Next is magma. Magma resources where 650 to 1200 degrees Celsius temperature you can find are still more temperatures are there. Okay. Coming to this environmental ish consideration or disadvantages. Say hydrothermal dry steam resource contain uh, non-condensable gases, mainly carbon dioxide and hydrogen sulfide, ammonia, methane, etc., which appear in turbine exhaust. So this is the disadvantage. Okay. Emission of carbon dioxide is significantly less than that from the fossil fuel plant with same output. Hydrogen sulfide is non-toxic gas like this. So we can go through. Okay. In wet steam fields, mineral and salt content of the hot water brine can be as high as 20 to 30% dissolved solids. This poses a liquid waste disposal problem. So like this, some of the disadvantages you can go through it. Okay, with this geothermal completely it is completed. Uh, Now, okay. Now, do you have anything to ask? Anything to ask? Anybody? Yes, Nihar, tell me. Nihar, do you have anything to ask?
Yes, sir.
Yes, ask me.
No, sir. No, sir.
Okay, right. Any doubt, any question? Okay, if you don't have any questions, um, all these things I have sent your email. Read it, write the sketches two times. Your preparation will be good. I hope all of you have put your USA number in the chat box. Class ends now. So again tomorrow 8:30, industry expert will be speaking on industrial point of view. Okay, now you may leave. Thank you all students. You can those who have not put your USA number, you can put the USA number in the chat box.